Yeah, so nowadays animation isn't really a thing which we can leave away when we're building user interfaces and data visualization. It has become quite a natural thing to use. But it is also something where I think a lot of people, including myself for a long time, didn't really have like a solid understanding how to use it exactly, and we were just using it and looking at other examples and rebuilding them and using our intuition and getting good results. But my plan for this talk actually is to give you also like a better understanding of the characteristics of animation, of how animations can be used in data visualizations. I'm going to talk about what can actually be animated and what are the principles and where can we go from there, from the current state. So I will start with the question, what is animation? So the technical definition is that animation is a series of rapidly displayed images which are perceived as motion. But the word animations comes from the Latin word animatio, which means the act of bringing something to life. So, and animus, the first part of the word, actually means soul. So animation essentially is the art of setting things in motion, making them appear alive. And if we are like considering some of the more traditional or rigorous data visualization theory, that may be a bit contradicting sometimes, because we don't want to make things, data look alive per se, but we want to display information correctly, right? So there are several characteristics of animation itself, of general animation, which I want to point out. And the probably strongest characteristic of animation is that it draws attention. You can't avoid to look at something which is bouncing around or moving. It is very effective at that. We can use this property to our advantage, but we also have to beware of the perils of getting distracted from what we actually want to tell. Additional to that, it's that humans can track 4 to 5 individual objects individually when they're moving. But if more objects are moving, then the eye will just follow a few and the rest is perceived as noise. So just keep that in mind when we are going through the examples later. Another strong property of animation is that it gives objects constancy. That means that when something is moving, we perceive it as actually staying the same object. It doesn't change. It doesn't turn into another thing. When something moves from left to right, it's still the same thing. We can track changes on objects in position, in size, in color, etc., like that. And this is also something we can't turn off in our perception, so keep that in mind too. Then another property is that animation groups similarly moving objects together. So even if they're not at the same location, when they move in the same direction with the same speed, they are perceived as a group of objects. Then more in terms of making things alive, animation suggests causation and intentionality of the things which are moving. So if two things are following each other, we interpret it naturally as them following each other or them bumping into each other, although it's an abstract thing on a screen, and maybe when we're animating some data points in a visualization, something like that happens, and the effect, the perceived effect is another than actually is happening. So. And this is also something which is in traditional animation, which is like cartoons or 3D animation, where the goal is to actually make objects or graphics look alive, is used to great effect, but it also can be, we have to be aware when we are using it in visualization. Animation is emotionally engaging. We find things which are moving more engaging than things which are static. It looks cool, it's attractive. On the other hand, it also may be that it may evoke frustration when something is moving too slow and it's not reacting fast enough to our input or something like that. It also can be a special form of chart junk when it's distracting from information. Animation is ephemeral. That means it makes it difficult to compare a before and a after when we are, for example, transitioning between two states in an animation. When we are displaying change over time, animating over time is not the best way to show the change or to measure the change for people. The next thing I'm going to talk about are three use cases of animation in the context of data visualization. The first one is animation used as a narrative tool. Animations can be used to support and drive a linear narration. And I will show you two examples where also the emotional qualities of animations are used to great effect. They are actually quite popular ones, so you may have seen them before. So what we're seeing here is a visualization about people being killed or having been killed by guns. And the trajectory of the points indicate the lifespan or the theoretical lifespan the people would have had. But at the point where they were killed, they just fall down. And what is interesting here is that it's although the objects are very abstract, they're just lines and dots which are falling from the sky, but just the fact that they are interrupted in their path and falling down onto the floor evokes a familiar feeling or tells a story what has happened to this abstract dot. I'm sorry for the blocky animation, but my computer isn't fast enough. So this is actually also, like, the topic is kind of similar. It's also about people being killed. And it's a visualization about drone strikes in Pakistan. And what we see here is that this narration has multiple steps. It introduces us very slowly to the topic. It introduces early the object or the method of visualizing a drone strike, which is this arc coming from the sky and kind of exploding, but it's still very abstract. And then we see the strikes falling over time. And as we will see, after a certain point in time, the strikes increase in number and frequency. So these are two examples of using animation to really tell a story, and I think they're more in the realm of traditional animation, where you really write a storyboard and animate something from beginning to end and have a story ready, and then you're trying to tell it. What is also interesting in both pieces is that these animations act as introductions to an exploratory piece, which at this point turns into a free mode visualization where the user can interact and explore different things. The second use case for animations is using animation as encoding for data or for information. First example I want to show is this wind map, where the information about wind strength and direction is encoded with moving particles. And coming back to the characteristics I mentioned before, is to stand out that there is like a natural grouping of particles which move in the same direction. And there's also, we tend to focus onto the area where there are many things, or things are moving more strongly or more faster than others. So we tend to look at the area around Denver in this case. Another example where motion or animation is used to encode information is this piece from the New York Times, where the speed, the rotational speed of the planets around their suns is mapped to the animation. And what is also key here is that we're not trying to make an exact statement about the speed, but it's just used as to see in this huge number of planets that they are relatively moving faster and slower to each other. So there's actually a lot more information in this graphic. And one of the key points here is also that the movement is quite natural, so it's not abstract in the sense, so it mimics the actual movement around the sun. Whereas in this map, movement is used to indicate the change in political votes. And what is interesting is that this isn't mimicking like a real behavior, because people aren't moving to the left or to the right physically, but maybe politically. So this is kind of a political wind map, so to speak. Another project which we did was visualizing the radiation exposure in Fukushima, and this could have also been done with a very simple bar chart, and it would probably have been more accurately readable. But we also wanted to bring a certain emotional and immersive quality to the visualization, and it also works very well when integrated into the text. I took it out from there.
Sorry, what does that mean? Sorry, what's that? What are you showing there, please?
That's actually different levels of radiation. It's the unit is microsievert. Yeah. So, and we wanted to make like this invisible radiation. So the original piece, I didn't include it here because the performance wasn't good enough. was like the top left corner is equal to the radiation exposure when you're using an electric toothbrush, and the red squares are different areas in near Fukushima, the exposure, and you can compare the two. And I'm not sure exactly which one is the sort of allowed threshold, but one of the upper squares is like the radiation dose, which isn't dangerous, and then yeah.
Thank you very much.
Oh, sure. And the third and actually most widely used use of animation in data visualization is as a transition, which allows us to track changes across different states of a visualization. So I'm going back to this classic from Ben Fry for an example. It's a visualization of the human genome. And what I find very interesting is that it transitions between usually different coordinate systems, but still, although the transition is quite wild at some points, it gives us a sense of orientation, and we don't lose track of where is what. And transitions are actually what I want to go more in depth in the following few minutes. So Jeffrey Hare and George Robertson wrote a great paper on animated transitions, and they defined a taxonomy of what kinds of transitions we actually can use in data visualization. And I will go through them, and I will show you an example for each. So one is the transformation of the view, and this is defined as zooming or panning over basically a fixed image. So one example could be the transition where we move on a map from one point to another. And in this example, you'll see that the animation isn't just a straight line, it's interpolated nicely. It's done with D3, which provides this sort of interpolation function. Yes, this is one type of visualization of transition. And actually, funnily, the images at the bottom also zoom and pan. But yeah. Then another type of transition is a change of the representation. So if we have data points and we visualize them in some way, there might be an alternative view on them which is more interesting or shows a different aspect. So for example, when we have data points or on a map, they can transition into an alternative view, which makes it more easy to compare in this case, the Swiss cities to each other, and can transform back to a geographical view, so people can actually find like their city more easily. And the transition, as is also quite a wild one. It's not easy to follow, but still it maintains a relationship of the objects. So you get the feeling that the red bar from Geneva at the bottom left is moving up to the top right there. Then the next thing is transformation of the surface, which means instead of transforming the view where we just move the image, we actually change the underlying system. Maybe we transform axis from linear to a logarithmic scale, or we transform a map projection, or we move things into an entirely different system. what is interesting here in comparison to the previous one is that we are not changing, or the representation of the actual data points is not changed at all. It's just that they are moved into a different coordinate system, which allows for different kinds of interpretations. The next type of transition is the Timestep, which is simply we move forward or backwards in time and values change in our visualization. So one example would be a map where we have a time slider and the map changes through time. But as I said before, the problem here is that it's difficult to compare the before and after state. So we are all just looking at one state at a time. And funnily enough, in this piece in the New York Times, there are like 2 more graphics below it, which allow for a more detailed view analysis of the data over time, which are static. Then we can change actually data structure, which means we can add or remove another variable to what we are displaying, or we can drill down or roll up. For example, like in the previous talk, we've seen a visualization where we could drill down into a continent and it would split up into multiple countries. In this example, we have a voting result or an election result, and we switch between viewing the current year and actually a comparison of 2 years. So we also change the visualization type to accommodate for the fact that we are in the second view, we are more interested in the change than in the actual value. So the slope of the bars, of the line tells you if a party has lost or gained during the last period. Then there are 2 more. There's reordering. This one is simple. We just, for example, focus on one dimension or sort by another dimension, and we can transition the ordering. Then there's also filtering, which allows us to filter out or in different data points. Oops. Anyway. Yeah. So we're seeing that when something is filtered out, it is faded out, and the remaining data points move into their places. So in the same paper, there are 10 principles defined for effective animated transitions. And as I first wrote commandments, but then I thought they're not really commandments because you can't follow them all the time. So the overarching core principles are called congruence and apprehension. So that means that the principle of congruence states that the structure of the external representation should correspond to the desired structure of the internal representation. In the case of a data visualization, that means the structure of the data. For example, the key aspect of an animation, time, could correspond to change over time, or in the form of movement or transformation of objects. On the other hand, animated graphics should be easy to apprehend by the viewer. Therefore, they should be slow and clear enough. The movement changes can be perceived. The first principle of congruence is that we respect semantic correspondence. That means we recognize that objects are tied to their internal data. So we don't replace marks on the screen, objects on the screen, involuntarily when it doesn't correspond to the underlying data. We should avoid ambiguity. That means that we should make transitions which have a different meaning actually look different. For example, a change in a value should animate the height of a bar chart, but swapping out the dimension which is shown should look different from that. This one is interesting. We should try to maintain valid graphics throughout the transition. So basically that means if we would stop the transition in the middle, it should ideally look like a correct static graphic. This is very difficult to do, but it for example, means that we shouldn't use effects like squashing things in the middle of a transition. So we should maintain as much as possible of the appearance. This means that we should try to use similar transitions for similar operations. For example, removing elements should always be used, always be done as fading elements out across different graphic types we're using. So this improves learnability and consistency. Then we have the principles of apprehension. We should group similar transitions because this principle can be used also to discriminate groups of elements. So, and similar changes are perceived also as a group of changes. We should minimize occlusion. That means, for example, when we are reordering things, data points tend, or objects tend to overlap in the middle. So one approach to solve that would be to stagger the reordering in time, so things move after another. We should maximize predictability, which means that we shouldn't introduce unexpected changes in mid-motion. So when an element starts moving, it should continue to the end of the movement. We should use simple transitions because they're easier to perceive. And on the other hand, when a transition is inherently complex, we should split it up into multiple stages. And we should make transitions as long as needed, but not longer, whatever that means. But a reasonable rule of thumb seems to be around 1 second. Also, smaller movements can be shorter. And also, movements which correspond to direct input, for example, via interaction when scrubbing a slider, should be made as short as possible, because then the system would appear as lagging. I will show you 3 more examples, and then I'm done. Where I won't say too much, but here we see like different principles I mentioned before applied. So we clearly see that it's a pretty complex animation when we move through the different stages. So we see that the transition is staged. For example, the axis seems to move first, and then data graphics come in. I also think maybe at certain points a bit too much, but yeah, that's for us to judge how strongly we want to apply each principle. So this example shows very nicely also the staging, the staggering of the animation, so the individual objects can be perceived more easily. And it also shows the nice property of the constancy of this US representation, which stays permanent across all the different graphics. Yes, and here it's also, motion is very much in use, and I actually have two critical remarks here that, for example, when points are removed or added, they are simply replaced, and also that this particular movement where they head out into the map is not exactly meaningful in terms of what the data means, because they're just representing 1% in the grid graphic. But still, it can give a very nice effect. And I guess, with what I want to close is that we can try to be correct, but we must not leave out other considerations where we can make things nicer and more engaging for the users. So I hope you have some new inputs to actually build animations and to judge them when you see them. That's it. Thanks.
Questions for Jeremy? One in the back there.
The examples you just showed us, are they canned animations, or is there some sort of degree of interactivity between?
Most of them are based on or react on scroll animation. So when you scroll, then they move to a different state of the graphic.
Well, the second example was obviously too fast because there wasn't time to look at the graphic and read the words as well.
Yes, yes. I just scrolled through it to exemplify the transition between the graphics.
Some degree of user control of it.
Absolutely, yeah.
Okay, thank you very much.
Another question?
Mine was a similar one actually. On the drone strike one, I was interested. Well, there's a couple of things there. This kind of martini glass thing where you give people key messages at the start, which is quite unusual compared to all the other ones where you're giving it to explore the whole thing immediately. Do you think there's more of an appetite for that actually? Because actually what that did as well is it gave them the concept of introduce them to the concept of the actual using animation, the actual kind of bomb or whatever. But do you think, in this day and age where people want things immediately, they want to get straight into it, do you think there's still appetite for that, to actually give them something first before you throw them into the whole data set?
I think it depends on the subject. And I think in this case, when I saw it for the first time, it was very interesting. When I saw it for the 10th time, it was pretty annoying. So I guess you have to provide a way to skip it, but and as long as it's not overdone, I think it's okay.
Is that the same for when you went into the main product, if you like, and you introduced the timeline? Were there controls on the timeline, or was that like this? You talk about this kind of canned animation.
I think it was animated until it was like in its full glory at the end, and then you could start to interact. Yeah, it was a long time, but it also tells like the story, and it has a certain rhythm of which unfolds, and like the key point, like where Obama is sworn into office, and then suddenly, ba-ba-bam, or yeah, I guess that was the main point.
Any more questions? Okay. Thank you.
Okay, thank you.